All right, so this is genetics practice problems. You're doing this on 107. As I go through the problems, just pause the video and then I'll show you guys the solutions here. So for this very first one, how many offsprings are going to be white in color? You've got black is one of the traits, white is the other trait, and it tells you that it's co-dominant. Don't forget that co means both. So for my parents, one of them is heterozygous and one of them is black. So the black chicken would be BB, the heterozygous would be BW. And then, oops, I have a Punnett square right here. For my Punnett square, we've got BW, BW. And there we go. So it asks you how many of them will be white. To be white, which means you need WW, and that would be 0%. Alright, the next one, blue is incompletely dominant to yellow. 2 heterozygous flowers are crossed. How many would be green? So if it's incomplete, we know that that's a mixture. So that means that one of my colors, capital BB, would be for blue. Lowercase would be for yellow. And then heterozygous, capital lowercase, would be for green. Notice how I get 3 colors, right? So these colors are my main 2, and then this one is a mixture of those 2. One of my parents, both of my parents are heterozygous. That means I have capital lowercase, capital lowercase. In other words, both of them were green. Okay, and it asks you how many would be green, and so remember, for green, I'm looking for this, and that would be these 2 right here. So it is going to be 50% that are green. Alright, for the next one, green is dominant to blue. If a homozygous green potato and a blue potato are crossed, how many offsprings would have blue coloring? So, always potatoes. So how many would be blue? I can be green. I can be blue. Circle one of my parents, it is homozygous green. The other one is a blue potato. So for homozygous green, that would be capital, capital. The other parent would be blue, and so it's lowercase, lowercase. Fill this out in my Punnett square. Oh my god. Okay, so and I see how many are going to be blue, and remember we said that capital is going to be for green, to lowercase would be for blue. So since we're looking for the 2 lowercase, that would be 0%. This is an example of complete dominance. Remember, complete dominance means that if it's a capital letter like capital G, it will be green. So even if I have like this, that'd be green. If I have like this, it will be green, okay, because it's completely dominant. Number 4, colorblindness is a sex-linked recessive trait. If a woman who sees normal, so meaning her mother was colorblind, is crossed with a man who is colorblind, how many of their sons will be colorblind? So when we talk about sex-linked, remember, if you are XX, you are female. If you are XY, we are male. And then on the X is where you put all of your traits. We do not put anything on the Y ever. So right here, I've got XX, that will be the mother. I've got XY, that will be the father. I go back to the question. She sees, colorblindness, let's start here. Colorblindness is recessive, which means, let's use the letter B for blind. So capital B would be normal, you'd be healthy. And if you have lowercase b, you would be blind. Okay. So let's go over here. She sees normally, so that means one of her X's is capital, but her mother was colorblind. So let's say, for example, that she has a lowercase b. And I know that because her mother was colorblind. She marries a man who is colorblind, which means he has a lowercase b. Nothing goes on the Y, so I leave it alone. I'm going to go ahead and put this here, and then just like normal, we fill in our Punnett square. And notice that on this side, these 2 children are female, these 2 children are male. I'm asking how many of their sons will be colorblind, how many of their daughters. So if I look at the sons, it is these right here. This guy has a capital B, so he is normal. This guy has a lowercase b, so he is colorblind. So 1 out of 2 of the sons are colorblind. When I look at the daughters, this one has a capital B and a lowercase, so she is normal. This one has 2 lowercases, so she is colorblind. So 1/2 of the daughters are colorblind, 1/2 of the sons are colorblind. Alright, for this one, it asks you brown dominant to black, hairy is dominant to hairless. How many of the offsprings would be black and hairy? If both parents, not parts, that's supposed to be parents, if the parents are both heterozygous for each trait. So we know that capital B is for black, brown. lowercase is going to be for black. We know that capital H is going to be for hairy. We know lowercase is going to be for hairless. If we look back at the question, it tells me both of them are heterozygous. So both parents are going to be capital lowercase, capital lowercase. That's one of my parents. Capital lowercase, capital lowercase. Here's my other parents. If we are going to do the 2-box method, we're going to make 1 box for the color. We're going to make 1 box for the hair. So this parent had a capital and a lowercase, capital and a lowercase. The other parent, here we go. Okay, and then you just fill in your Punnett square. And fill in this side Punnett square. Alrighty, and now we're looking for how many would be black-haired and hairy. So to be black-haired, you have to have 2 lowercase b's. So I'm looking for all the 2 lowercase b's, and then to be hairy, I have to have at least 1 capital H. I don't care what the second H is. It could be a capital, it could be a lowercase. I don't care. Either way, as long as it has that first capital H, it'll be hairy. So I count from the first Punnett square, how many are lowercase? Lowercase, that's 1/4 times, and then how many have a capital H? That is 3/4. I multiply 3 times 1, which is 3. 4 times 4 is 16, and that's my answer. So 3 out of 16 will be black-haired and hairy. If we were going to do the large Punnett square, let's go ahead and erase this. If I were going to do the large Punnett square, this is my parent. That's one of them. And here's the other one. In order to do the other Punnett square, I have to do FOIL. So I would do FOIL. And then now I go to the lowercase b, lowercase capital, lowercase, lowercase. And then it's going to happen to be the same thing on the top. Again, draw your FOIL. And then we would fill in our Punnett square. I'm not going to go ahead and fill in all of it, but make sure that you are getting almost all of it. And again, you're going to look for the ones that are black and hairy. So lowercase, lowercase, capital, at least 1. And then you'd count them up, and you should get 3 out of 16.
Yeah, go follow me.
No! Ew, don't do that. Next.
Yo, go subscribe. Oh, she's short.
Oh, here, I'm ending it. Bye!